Good day to you. This is Anonymous 7. It was reported in the week of the 20th of November 2010 New Scientist, among other publications, that scientists working on an experiment called the Antihydrogen Laser Physics Apparatus, or ALPHA for short, at the CERN laboratory in Switzerland have managed to trap antihydrogen. This, inevitably led to a Nephi vid, but I do not wish to get too distracted by the scientifically illiterate imbecile, but I will briefly aside to say, chronologically, no, antimatter is not the same as dark matter. No, nobody claims either is the cause of the universe. No, nobody claims that antimatter is keeping galaxies together. Yes, scientists did capture an antihydrogen atom, which they also created. The two are not mutually exclusive, and if you understood the experiment, you'd know why. No, they captured 38, but made many more, which they couldn't capture due to their higher energies. No, antimatter is not prevalent in the universe. No, antimatter is not invisible like dark matter is. No, based on this experiment, scientists do not claim to have more evidence for the Big Bang or for galaxies being held together by dark matter. No, if antimatter were around a galaxy, it would not definitely fall into the centre of the galaxy, otherwise no spiral galaxy such as our own would exist. No, scientists do not claim that antimatter comprises the majority of matter in the universe. In all fairness to the Nefster, he did remove the video, but not after defending it on a mirror of the video, where he also made new flawed points. Regardless, let's get down to science. In short, antihydrogen is a hydrogen atom entirely composed of antimatter. Well, just what is antimatter? Antimatter was first tacitly suggested by physicist Paul Dirac in 1928 and proposed by him officially in 1931, and in 1933 the first antimatter particle, the positron, was discovered. The positron is basically an electron but with a positive charge. Nowadays these particles are routinely produced in massive quantities. In 2008, physicists at the Lawrence Livermore National Laboratory found a new way of producing large numbers of positrons by firing a laser at a gold target, producing billions of positrons. But what about the nuclei? Nuclei are composed of protons with a positive charge and neutrons with no charge, but this isn't the lowest level of particle in the nucleus. The protons and neutrons themselves are composed of particles called quarks. Quarks are, to the best of our knowledge, fundamental particles. That is, they can't be broken down into constituent particles. They have partial charges of plus 2/3 and minus 1/3, and come in 6 flavours: up, down, top, bottom, strange and charm, 3 having the plus 2/3 charge and 3 having the minus 1/3 charge. In the standard model they are joined by leptons and bosons which carry the forces. The quarks and protons and neutrons are of 2 flavours, up and down. Up quarks have a charge of plus 2/3 and down quarks have a charge of minus 1/3. So a proton is composed of 2 up quarks and 1 down quark, producing a charge of plus 1. A neutron is made of 1 up quark and 2 down quarks, resulting in a total charge of 0. Like electrons that have positrons as their antiparticle counterpart, each of these have an antimatter partner, again with equal but opposite charge, although they do not get their own name like the positron does. The prefix anti is simply added to quark in their name, i.e. the antimatter counterpart of the up quark is the up antiquark. As such, an antiproton is made of 2 up antiquarks and 1 down antiquark, resulting in a total charge of minus 1. The antineutron is made of 1 up antiquark and 2 down antiquarks, although, as this is antihydrogen, antineutrons are not involved. An antihydrogen is simply, you guessed it, 1 antiproton with a positron in tow. It was first synthesized in 1995 when 11 were produced. The relevance and excitement of this latest experiment is that antihydrogen atoms were trapped by the team using hugely powerful superconducting magnets. You see, whilst antiatoms are electrically neutral, they've got an antiproton of minus 1 and a positron of plus 1, they do behave like tiny bar magnets, so can be manipulated in a magnetic field. The difficulty is that they must be travelling very slowly for this to work, as the response to the magnetic field is weak. The experiment was run 330 times, and in total 38 antihydrogens were moving slowly enough to be trapped after utilising some 10 million antiprotons and 700 billion positrons. It's not a particularly high hit rate, but it's early days, and the team feel that a new antiproton cooling technique will improve the success rate. Now that antiatoms have been trapped, they can be studied to see if they follow the same rules as normal atoms, for example their absorption and emission spectra, which should be the same. If it isn't, significant reworking of the standard model, or even replacement of it, will be needed. Thank you for watching. Mouse out.